Right, question 3, it says draw the graph of f of x plus 2. Now notice the transformation now is in the bracket, okay? So this is your f of x here, of course, and now we want f of x plus 2. So the transformation will be this shifted, but of course when it's in the bracket, you go the opposite way, okay? So you're going to go in the negative direction, so minus 2 if you like. When you see plus 2, you do minus 2 along the x-axis. So if you go minus 2, you've got to think about that there. That's the origin. So it's going to go back to minus 2. This is going to shift to 2. Think about where that's going to shift. Okay, so I'm going to draw my axes, and I'm going to be careful here to have a little bit more of the negative values for x on my new graph. Okay, just to recognize that. So this will go, if you shift that back 2, you end up there 2. Okay, 2, 0. This minimum point, if you shift this back 2, take away 2 from that, you get 0, so it goes through there. Okay, so 0, and that will be minus 4. Now the y value is unaffected, don't forget. And then that's 0, the origin, so back 2, you end up at minus 2, which is about there. Okay, so you've got minus 2, 0. And you can draw your graph, okay? And that is f of x plus 2. Okay, excellent. Then it says, given that the equation f of x plus 2 equals k has 2 real and distinct solutions, find the range of values of k. Alright, now what we need to see here is a different question to what we saw before. It's got 2 real and distinct solutions, right? But it's not saying here when it's equal to 0, okay? Because of course we know, it equals to 0 here, doesn't it? And it equals to 0 here. So we've got 2 real and distinct solutions. We know all about that nonsense. But here it's saying, given that it equals to k, and it always has 2 real and distinct solutions, find the range of values of k. Well, it doesn't have to be here, doesn't it? Where it's got 2 distinct solutions, 2 real and distinct solutions. It could be up here, couldn't it? If you notice up here, you've got 2 solutions here. So when we say equals to k, it could equals to, let me just put a few lines in, it could equals to 4. So suppose that was 4 there, okay? I'm just making this up, but if it was equal to 4, in other words, if k was equal to 4, okay, then you'd have 2 real distinct solutions. It doesn't have to be 4, it could be there, it could be 2, But notice again, you've got 2 solutions for it, okay? It could be anywhere. In fact, you could keep going, couldn't you? All the way to infinity, you'll always find 2 solutions, okay? And even down here, negative values. Okay, so when the point I want you to get is when this says equals to k here, we're talking about values on the y-axis. Okay, here when it equals to these values here, of course that's what it means, isn't it? When you've got f of x or f of x plus 2, the graph, when it equals to a value, the value is on the y-axis. So it's got 2 solutions. It's got 2 solutions here as well. The moment it stops having 2 solutions is here, of course, at the minimum, because at the minimum, okay. The minimum, it actually only has 1 solution, doesn't it? Or you could think of it as having 2 solutions, but it's repeated, isn't it? If you remember doing that, it's repeated. We think of it as 1 solution, yeah? It'd be better, it's easier, clearer to think of it as 1 solution. So there, it's no good. Less underneath there, it's no good. So anything above minus 4 is fine. So we'd say k has got to be greater than minus 4. It can't be equal to minus 4, because it's got to be less than it. Okay, it's got to be above it, so you get 2 solutions. Okay, so this one now, number 4, f of x minus 5. Now remember, in the bracket you do the opposite, so we're going to actually go plus 5, okay, along the x-axis. So, excuse me, for that, you're going to need quite a bit of x-axis, okay. Remember now, these graphs are not like drawn to scale perfectly, right, so don't worry, just as long as it looks reasonably good. There, it's going to go along 5, so you end up there, 5, 0. Okay, this is going to be shifted along 5, so if you think about it, that will become 7. The y value stays as minus 4, and then shift that along 5, you get 9. 9, 0. Okay, there's your graph there, something like that. Anyway, it's not very well drawn, but it's okay. You've got the values in there, that's the main thing. Make sure the values are nice and clear. So it says then, given that the equation f of x minus 5 equals k has no real solution, so find the range of values of k. Now remember, as we saw before, if we're up here, that's no good. Okay, so if we take k to be 4 or whatever is there, right? That's no good because it's got 2 solutions. No good at all. We want no solutions. So if you think about it, k has got to be down here somewhere. Okay, k has got to be down here, isn't it? But there's no solutions. In fact, k has to be underneath that minimum point. Okay, it can't equal that minimum point because you'd have one solution. It's got to be underneath it. So k in this case has got to be less than minus 4. Okay, and we've answered our question.